I'm Raphael, and I'm doing work experience here at Menlo this week. Quantum physics is the study of particles, the way they behave, the way they interact with each other, and we're measuring these particles at the smallest atomic level. Many applications, but one that I'm really interested in is quantum microscopy, where you can use these microscopes to look at chemical reactions, and these would not interfere with these chemical reactions in the same way that light microscopy does. Frequency comb is a special type of laser that allows you to make really precise measurements of certain things. So one that I'm really interested in is optical clocks. They can be used to measure these light waves and then convert them into more readable light waves of a lower frequency, which can then be measured by classic technology. So an optical clock is a clock that uses light in the visible range of the spectrum to interact with an atom, and then the oscillations produced can be measured. And this is different to the atomic clocks that are currently used, which use microwaves. So quantum entanglement is when atoms interact with each other in a certain way, and then these have impacts on each other so that you can't describe one of these particles in the group without first being able to describe the rest of the particles in that group that are entangled together. A quantum computer uses qubits as the unit of information instead of bits, and it's thought that they can have higher computational power and they can complete certain algorithms quicker than classical computers. What I'm particularly fascinated by is the fact that you can study such small particles and describe how they behave, and then also how this has such relevant implications on the world as a whole, on such a large scale. Exciting. Countless things, but I've learned how to assemble lasers, how to test lasers, the whole production line. I've learned about optical frequency combs, and I've learned how to operate in the scientific world and in the workplace.